Hi everyone, I hope you're doing well. In this video, I will answer questions about LLMs, word embeddings, tokenization, LLMs temperature, context window, prompt engineering, and zero or few shot learning. In the next separate video, I will talk about concepts like RAG, sequence-to-sequence models, transformers models, encoders, decoders, and so on. So let's start with the first question, which is what are LLMs? The term LLMs, which stands for large language models, can be split into two parts. The first part is large, and we call these models large because they have been trained on a big quantity of data and their neural architecture is very deep with many layers. And we call them language models because they are able to understand, generate, and predict language like human does. And the result of training these kind of models is billions of well-weighted parameters that make these models excel at tasks like translation, summarization, and question answering. Now, the next question is, what are word embeddings and how are they initialized in NLMs? So word embeddings are vectors representations of text, and these representations are dense. This permits the model to capture semantic and syntactic properties, and before being trained, they are generally initialized either with random values or with values from pre-trained models like GloVe, Word2Vec, and so on. If you look at an example to explain this further, let's take these words. These are their vectors representations, as you see, composed of floats. Each column represents a feature related to this word. For example, a cat has a higher weight related to a living being than the weight to be plural or verb. So this gives more information to the model about the word meaning. If we look at these three words representation in a 2D space, we see that a cat is closer to kitten than to dog, and woman is to man like queen is to king. And again, thanks to word embeddings, we have this kind of semantics and equivalence between words. Now, what is tokenization and why it's critical for LLMs? So tokenization is actually about breaking down text into smaller units called tokens. If I give you an example, let's take the word artificial. This can split down into artificial like this. The word can be split down into three subwords, which are these ones. The question that we ask here, why are we doing this? This is actually a vital process for LLMs because the tokenizers models behind are actually trained on these subwords and are not able to process full representations of words, but they need to break down words to process them. And this has many advantages as well because thanks to tokenization, models are able to handle diverse languages or rare or unknown words. And these unknown words are called out of vocabulary words or OOV, which take us to our next question about OOV. So let's say that our word here is cryptocurrency, and cryptocurrency, as it's not part of our vocabulary, for example, it's called OOV, means out of vocabulary word. That's why when processing this word, LLMs might split it into two subwords, crypto and currency, which are actually part of our vocabulary. And this ensures that models understand words that they receive by splitting them into subwords that they know in their vocabulary, and also results in a smaller vocabulary because we are not necessarily building our vocabulary from all the words that exist in the word, but will be composed of these small parts of the word that can be common to different words. The next question is about temperature in LLMs. So temperature is actually a hyperparameter that adjusts randomness in the output. It means in the generated text by the LLM. more specifically in the choice of the words that will appear in the output. Values are generally between 0 and 2. A low value equals to 0.3 favors high probability tokens. It means tokens with high probability to produce predictable outputs, and setting the value of temperature to 1.5 increase the model's diversity or creativity. It means that we give to the model the chance to be creative in generating its output and telling it don't necessarily choose words with high probability. So the value temperature is generally set around 0.8 to kind of balance the creativity and coherence. Next question is about context window. So the context window is the number of tokens an NLM can process at once. It actually defines all the information that the model can put in its memory, short memory, let's say, to understand its output, and this includes understanding the input and generating the output. It's to be noticed, guys, that having much information in the LLM prompt will increase the use of this context window, so it increases computational costs, which is not practical in production, and it could affect accuracy as well. So it's important to balance the value of window size when we deploy models in production. And of course, one of the most asked questions in generative AI interviews is about prompt engineering, which is about designing inputs for LLMs. Prompts can be as clear and simple as summarize this article in 100 words, or they can be more complex, containing more instructions, or even examples of the task to guide the model. And this is what we call few-shot learning, which is also a asked question in interviews. And few-shot learning is very practical because it permits to add more knowledge to the LLM without necessarily training it from scratch or fine-tuning it. You just need to put this information in its prompt or in its short memory that we talked about in the context size question. And this is very crucial, guys, because it permits to have remarkably better results just with few examples, and this can be fast and with low costs. And as we have few shot learning, we also have zero shot learning, which means, as its name indicates, we use zero examples to perform downstream tasks. It means that the LLM will use its knowledge that it learned in the pre-training phase to perform a downstream task. So if we take sentiment analysis task as an example, we ask the model to classify a review as positive or negative without adding any example of the task to guide the model. And in this last question of this video, we talk about chain of thought, which, as its name indicates, it permits to proceed with a chain of steps to solve a complex problem. So this is exactly like how human beings do. If we take a math problem, for example, we reason step by step, we break down calculations into smaller steps, and we transform the initial problem into smaller sub-problems. This is it, guys, for today's video. In the next video, I will answer 10 additional questions that are often asked in Gen AI interviews. Don't hesitate to subscribe to the channel to get notified about these videos. Thank you guys for watching, and please don't hesitate to ask me questions in the comments about any concept I talked about, and see you next time.